4 vertices and 2 triangles, and I remade the graphics because it was really ugly. So basically, a tile is 4 vertices and 2 triangles, 0, 1, 2, 3, right? And the triangle are the indices 0, 1, 2, and the triangle B is 0, 2, 3, right? And here we have the vertices position. And in our code, this is right. This is I don't know how I'm going to do this, but yeah, this is here, right? We had each vertices 0, 0, 0, 1, 1, 1, 1, 0, and then triangle at 0, 1, 2, and 0, 2, 3. So that's cool. But now we want to blend with the texture, with the neighbor texture, right? So for what? Oh. I made some tests between video. So what we want to do, for example, here we want this mesh, the mesh of the dirt here, to overlay the grass, right? Or it's the opposite actually, because the grass is on top. Yeah. So we want the mesh of the grass to overlay for one tile the dirt, right? And then alpha blend on top of the dirt. That's what we want. So to do this, this is my way. I don't know if this is a better one, but it's working. So what we'll do is for each tile, we'll have a list with each neighbor terrain type. For example, here we have water, grass, dirt, and rocks. But only the terrain types, they are not the same at the tile. So water, grass, and rocks. So we'll have this, right? Water, grass, rocks, because this one is the same, so we don't need to blend here, right? And then we will have an array, right? With for each neighbor the terrain type. For example, 0 is rock, 1 is water, 2 is water, 3 is water, 4 and 5 are grass, 6 is dirt, and 7 is rock. Right? Then what we do is for this tile, for each terrain type in the neighbor terrain list, we'll grab the mesh, for example, the rock mesh here, right? We grab the rock mesh, and we will check for the rock mesh, we will check what neighbor terrain is equal to rocks, right? So for example, if here 0 is rocks, right? Imagine this graph on top of T. We'll need to color the vertex 1, 0, and 7 in rocks, right? Because it's on top. This is over, right? This will be here, basically, right? So we'll need to color the bottom vertices, which will be 1, 0, and 7. But I will explain this later in a better way. And for each neighbor with different, we will subdivide the mesh in 4 rectangles, right? And this will be our indice and our triangle. So we'll do 0, 1, 2, 3, 4, 5, 6, 7, 8. And this way we have a cool thing where we have only odd numbers for the angles, and that's kind of important for later. I will explain why, but yeah. So for example, this triangle is 0, 8, 6, and this vertex is 1, 0, 5, right? 1 on x and 0, 5 on y. So let's do this. This is going to be fun, right? So first, for each tile, we need to have neighbors, right? With these indexes. So let's do this first. So let's grab a tile, right? Yeah, and let's make an enum direction with south, southwest, west, northwest, northeast, east, and southeast. And that's 8, right? 4, 4, 8, yeah. And for this example, we'll do something simple, like make an array of neighbors. But you could do this a more elegant way. For example, assigning to this a list of vector, and south would be y minus 1 and x0, and just add this and make a getter in the map. But yeah, this is fine for now. And we'll make a method called setNeighbors, right? And what we'll do here, so we can do it this way, right? Or we can just put 0 here, right? This is the same thing, because this is 0, this is 1, but let's do it like this, it's easier to read. That's 8, right? No, it's 7, 8. So let's make them all. Sorry. Yeah. So this is minus 1, minus 1. This is minus 1, 0. This is minus 1, plus 1, yeah. Plus 1, 0. Plus 1, plus 1, right? Plus 1, 0. And plus 1, minus 1, right? I think this is correct. Yeah, I think this is correct, yeah. Yeah, because if we had an array who contained for each, like 0, 1 for south, for example, we could just do this dot map dot cell dot well, we could do something like tile dot position plus south, right, to get the south name, right? If we have a list of vectors position. But this is fine for this example. So now let's set the neighbors, and with this way we can't do it here because everything is not defined, but it's okay. xy.set neighbors, and this should work, I guess. Where is Unity? I just need to check if I have a mistake or not. Yeah, nothing exploded, so I guess we're okay. Fine. So now we have neighbors, right? And in the map mesh, we will copy all of this, right? And this is kind of annoying to use, so let's make a method like add triangle actually, that is index like, and how do we do this? Something like this. Yeah, we could do something like this, or something like do something like this, right? And 0, 2, 3, and let's add it to the mesh data. VI is vertex index, right? Sorry. Right. And this should work, right? Yeah. We could do the same for this, but it's... let's check if this works. I don't see why not, but let's check anyway. Oh, I have to function called gen. So let's call this one gen mesh blending. Yeah. So it's still working. Nice. So now, what we want to do, if we follow the explanation here, we want a list of each unique different parent type around the tile. So this is quite easy. We can use a hash set actually. I don't know what is best. I think a hash set is best in this situation. Well, yeah. Let's use a list to not complicate things and go into infinite debates. So we'll call this neighbors unique different parents, right? Why not? And now we need to check this. So first of all, this will be cleared for each tile. And we will do the code here. So we need to check each neighbor, and we know we have 8 neighbors, right? Because we define this here. Yeah. So for each neighbor, we need to grab the neighbor, right? So type.neighbor, right? By the way, this can the neighbor can be null, right? Because for example, yeah, for example here, right? For 0, 0, the south neighbor is null, right? But in this case, we don't have to blend, so it's okay. So what will you do if how do I do this? Right. Yeah. If neighbor is different than null, right? And neighbor and parent type different the type and parent type, because we don't want to add it if it's the same. Yeah. And parent but not or very, very long name. That contains neighbor dot term type, right? Virtual long name dot add neighbor dot term, right? Yeah. Basically, we just want to do this for now. And after that, what we want to do, I will rename this. Okay. Yeah. Okay. So for each Terran type in this thing, first we want to grab the mesh. So let me explain this. So we have our list of water, the grass, and rocks, right? And now we for each on, for example, here we are at rock, sorry. Let's say rock is the first, right? I don't really care. It's just an example. So we are now in the rock mesh, and now we need to add this at the tile position, right? We need to add this at the tile position. So let's do this. So we have 8 vertices, right? So let's copy paste this. So 1, 2, 3, 4, 5, 6, 7, 8. And trying to do something smart, right? Okay. So the first one is this one, right? The 0 here. So it's x at .5, right? The second one is 0, 0. Then 2 is 0, .5, right? This is plus 1, right? And then I'm just following this, right? This is basically this explained. So 0, 1, plus 5, plus 1, 1, 1, 1, 0, and 5, 5, right? Because it's the center. So we add the vertices, and then we need to add the triangles. And the triangle is 0, 8, 6, 0, 6, 7, 1, 8, 0, 1, 2, 8, yeah, 2, 2, 4, 8, 2, 3, 4, 8, 5, 6, 8, 4, 5, right? Sorry, I mix French and English here. So let's copy paste this, right? And so we have, fuck me, 4, 5, 6, 7, 8. 8 triangles. And 8, 6, 6, 7, 6, 7, right? No. Right, 0, 1. I'm just duplicating what I prepared before, right? 1, 2, 8, 2, 4, 8, 2, 3, 4. And I'm sure there is a way to simplify this using like maths. but I'm too lazy right now. So yeah, that should be this, right? So what we do now is we draw. Oh fuck me. Yeah. We draw at the tile position this thing, but on the rock mesh, right? Because we will get the mesh we put in. Well, let's call it the same way that in auto explanation, right? Neighbor terrain list. Right. So let's check this. So nothing changed, but if we check this in interesting. Oh, yeah. If neighbor.terrain list don't contain terrain types, because if we do the opposite, we will never add something in it. That seems crazy, right? Yeah, that's kind of fun. Yeah. I obviously made a mistake. 4, 4, that's, I'm missing 1, right? 9, 3, 3. Yeah, I'm missing 1 vertex. It's 9 vertices, right? 0 to 8. So let's check which one I'm missing. 0, 5, 0, 0, 0, 0, 0, 5, 0, 1, 0, 5, 1, 1, 1. One, 0, 5, right? Still fuck up. What did I do wrong? 0, 0, 5, right? 0, 0, right? I'm just checking it's my list. So 0, 5, right? 0, 0, right? 0, 0, 5, right? 0, 0, 1, right? 0, 5, 1, right? 1, 1, 1, 0, 5, 1, 0, 0, 4, 0, 4. So the vertices are good, right? Let's check the triangles. So 8, 6, yeah. 0, 6. I'm too stupid. I need to. Yeah. You. Did you get it? I'm getting a new mesh, but I'm not getting the new vertex index, right? So. And this is cool. And now, if we check this, we have exactly what we want. Because for, like, yeah, I will explain this later, but see, the water tile here is surrounded by dirt, right? So the dirt is on top, so we need to draw this on the dirt mesh around the tile, right? And we still need to draw the dirt tile, obviously. But around it, we need to draw like this. Okay? So more exactly for each tile, for example, for this tile, right? We know we have a south neighbor with dirt, so we are creating this here. Right, and the same for the tiles. So let's add some stuff. we need some colors, right? We need some colors. So let's add some color. Let's define the colors, the new color 9. Because we have 9 vertices, right? And let's match data dot colors dot add color dot white. So that's that's the vertex color of the 4 initial vertices, right? So it's white. We'll just use the alpha. But yeah. And here, what we'll do is for each vertices, right? And we have 9. Well, we can do this actually. Well, we can. Yeah, we can. Okay. 0 to 8 is 9, right? Yeah. Let's do this and let's add the colors to the mesh data dot colors dot add range colors, right? I just modify the shader to multiply by the alpha of the color of the vertex, right? I just added. It was commented before, just uncommented. So let's check this. So yeah, now if you take our dot mesh, we have the surrounding is transparent, right? And this is and the middle is normal, right? As you can see, we draw some triangles here and vertex, but we know the dirt is on top, right? So we don't need to draw them. So actually, what we can do here, it checks here at the condition int neighbor.terrain type is superior or equal int tile.terrain type. Because in tile, terrain type is an enum, so this is 0, 1, 2, 3, right? So we know rock sits on top of grass, grass sits on top of dirt, dirt sits on top of water. So if we add this condition and hit play again, now you see water will never have blending because it's a layer on the bottom, right? But dirt has everything, right? And as you can see here, because we have some rocks on top, we don't draw them, right? So it's kind of important to do this. It's not mandatory, but it's a lot of vertices that are not used, right? So now what we need to do, it's quite simple. So for example, right? So now we are on the rock mesh, right? And we draw this. We draw this on the rock mesh at the tile position, right? And for example, we know the south is rocks, right? So if the south is rock, we need to put this to white and all the other vertex to clear or transparent, right? But like I said, we have even numbers here, but odd numbers in the angles. And if we check this, like, because we use the same order for the vertices and for the neighbors, right? If here, right, if 7 is rock, right, if 7 in rock, we need to put the 7 white and these two transparent, right? So if yeah, so if the neighbor on an angle, right, we just need to change but basically what I'm saying is, because we did the neighbor and the same order as the vertices on the small mesh here, right? We can just say if neighbor southeast is rocks and I'm on the rock mesh, right? Put these vertices to white and the others to clear. So let's do this and check what it does. So only for odd numbers, right? Because this is not going to work for everything. So if terrain type equal neighbor terrain list dot array. So we are on the rock mesh, for example, and we check that the current terrain type is equal neighbor terrain list with the array who contain for each neighbor the terrain, right? So if this is true, we just need to do, and this is a not number, because like I said, I is the neighbor index, but it's also the vertex index, right? Because 1 is 1, yeah? So if we do just this, let's check what it looks like in Unity. Okay. What? Index was out of range, must be non-negative. Line 68. Oh, yeah, right. We didn't fill this array. So let's do this. I said since earlier we need a neighbor terrains, right? So let's make a neighbor terrains. Yeah, that's not how it works. So we have 8 neighbors, right? And here. So if the neighbor is not null, right? The neighbor terrain, the oh yeah, the neighbor terrain I is neighbor. Fuck me. Dot right? But what do we do if neighbor is null, right? If neighbor is null, what we need to do, and I will explain this later, but let's comment this for now. So what do we do if neighbor is null, right? Because for example, as you can see here, for 0, 0, the neighbor are null, right? But we don't need to blend, so we can pretend this is water. So we can pretend this is the same as the current tile, right? So what we'll do, if neighbor is null, we'll say neighbor terrain I equal tile dot neighbor terrain. Dot terrain type, sorry. So, yeah. This way, now we have a terrain type for each neighbor, right? So let's uncomment this now. And we got the same error. Declare, right? We have 8 neighbors, right? We set them all. If it's null, we do put the neighbor. If it's not null, we put the terrain tile. Yeah, that's correct, right? Before I change this, if terrain type is... Sorry, my naming is kind of shitty on this. So, now what do we have? We have this. And it's kind of cool because, you see, we check this tile, right? And we detected that we had a neighbor on the southwest who was dirt, right? Who was not the same at water. So what we did is we put this, we put these vertices to white, the one here, right? But we can do this for this, okay? So for this one, for example, or for this one, yeah, let's do this for this one, yeah. So for this tile, we detected we had a neighbor at the southwest who was here, for example, right? Who was dirt. And what we did is we just put the one here to white and the rest to transparent, right? And in the shader, because we multiply the texture by the alpha of the color, right? White is 1 and transparent is 0. And we change the vertex color. It does this blending, right? And that's exactly what we want, right? So now we have done all the angles. But what do we do for this case, for example, right? Yeah. If we have something, the rock at the south, we need to put 107. We need to put 107 to gray, right? To white. Sorry, we need to put this to white and this to transparent, right? So how do we do this? So if it's even, but still, if the current red type is a neighbor, because like here we are on a rock mesh, we don't care if the south is not rock. If the south is not rock, we don't touch anything, right? But if the south is rock, and south is... Let's do a switch here. Yeah. So if the tile of the south is so south is 0, right? In our neighbor indexing and in our vertex indexing, we need to put 107 to white. So let's just do this. Yeah. Exactly like this, right? Let's check. Now we start to have something like this. Because this is not a good example actually, but yeah, well, this is kind of this is a better example, right? because you see on this tile we know we had grass on the south, so we put all this to grass, right? And it's working. So let's do this for all the even number. So we have 2, and let's copy this actually 4 times, right? So we have 2, 6, and 2, 4, and 6, right? So what do we do for 2? For 2, we need to put 1, 2, 3, right? For 4, we need to put 3, 4, 5, because it's the north, right? And for 6, we need to put 5, 6, 7. Right? And if we check this now, it should work actually. I have kind of a bug. Why? I must have missed something, right? Yeah, okay, it was a stupid mistake, my bad. Because I was killing the color here, right? And we can enter this loop 8 times, actually. And we can set multiple things white, right? So I need to do this like this, right? And we just talking. I'm sorry, that was a kind of stupid mistake. But now it's working, right? Everything looks beautiful. And we will add the so we just do this, right? Enter the color to clear, then set them, right? And we uncomment this, and everything should be fine, right? And now it's working, right? And it's kind of beautiful. Yeah. So I will show you the shader if you want to copy it. It's nothing special, but basically the only thing different with the base and light texture is the transparency, and I generate the UV using the vertex position, right? And if you do this, basically one tile, it's a texture resolution, right? If you do it like this, our texture of 500 by 500 will be in one tile, and if we do this, it will cover 8 tiles, and with do this, it will cover 24 tiles. So basically, it's the resolution, the pixel per unit for the texture in each tile. Yeah, and we just multiply the texture color by the alpha, and we set the alpha to 1 or 0, basically. We can pass just 0 or 1 and not use the color here, use a custom value, but it's simpler this way, right? So, yeah. And it's working, and we can do a big map if we want to. Where is my mesh runner? Oh, it's already 100 by 100. We can do much more than 100 because, and this is in Unity Mesh are U shorts, right? So it's something like this. Yeah, it's limited to, that's the match, right? Something like this. I don't know exactly, but it was 65, okay. Oh. So what you will do in your real game you will divide your map by section, or 10 by 10, or 50 by 50, or 100 by 100, right? And you will do a map section mesh instead of a map mesh, right? And generate on this section who are visible with the camera. Yeah, because here we draw everything, but our camera is just showing this, right? So it's kind of stupid to generate the mesh for everything else. So yeah, in real game we do that. In my game I just generate the mesh. You can, right? That's the point of. But that's optimization, and I think you should be able to do this yourself if you followed this tutorial. But yeah, it's quite a nice result, right? And even if we look closer, still kind of nice, right? And yeah. So I hope you enjoyed this tutorial, and see you later. Bye bye.